So my name is Anna Sue. I'm an associate professor in the Faculty of Law here at the University of Toronto. I'm also one of the research leads at the Schwartz Reisman Institute for Technology and Society. This afternoon session is entitled Navigating Autonomy and Accountability in AI Agents. It's a topic that touches on some of the most pressing questions in AI today as AI systems become more autonomous, forced to grapple with issues of responsibility, governance, and trust. So who's accountable when an AI makes a harmful decision, and how should our legal systems evolve? To help us unpack these questions, I'm excited to introduce our two speakers for this panel, who are both joining us virtually. I'll introduce our speakers in the order that they're speaking. First, we are being joined virtually by Atrisha Sarkar, an assistant professor in electrical and computer engineering at Western University and a faculty affiliate here at the Schwartz Reisman Institute. Atrisha's research spans multi-agent systems, behavioral game theory, and computational methods for ensuring AI safety in human-centered contexts. Her work has tackled challenges ranging from autonomous vehicle safety to online polarization and human-AI interaction. Fun fact, she was part of the team behind one of the very first self-driving cars to hit the roads in Canada. With a PhD in computer science from the University of Waterloo, Atrisha brings both technical depth and an interdisciplinary approach to these critical issues. Our second speaker is Megan Ma. Megan is the executive director of the Stanford Legal Innovation through Frontier Technology Lab, or LIFT Lab. Megan's work focuses on how generative AI is being integrated into legal practice, from translating legal knowledge into code to understanding the broader implications of human-machine collaboration in the legal field. Beyond her research, she wears many hats. She advises the PairX for AI program, serves as editor-in-chief for the Cambridge Forum on AI Law and Governance, and is the managing editor of the MIT Computational Law Report. Megan holds a PhD in law from Sciences Po and has taught courses on AI and legal reasoning, legal semantics, and public health law and policy. She brings a wealth of knowledge at the intersection of law and AI. So without further ado, please join me in welcoming both Atrisha and Megan. Atrisha, we'll begin with you. The floor is yours whenever you're ready.
All right. Okay, so I've started sharing my screen. And so I'm going to talk about how we can build safety in multi-agent systems with agents, meaning that we are using agents to talk about human social systems, and of agents, meaning that how we can build safety of agents that interact with humans. Now, there's a lot of focus on AI agents now, and to the point that we can say that it's a buzzword. But for many in the audience, we would realize that these agents as this idea of problem-solving entities with specific goals, which have autonomy and with rational, responsive, and strategic behavior, goes back at least few decades. And in my own field, it goes back at least 25 years, and some other fields like social science and philosophy, even many, many years before that. The modern incarnation of these agents are often as a front of an underlying LLM system, which interacts with humans and other autonomous agents participating in our different social and economic systems. But there are also agents that are, for example, like autonomous vehicles, which are backed by not an LLM, but a really complex architecture with several individual modules where each of them are driven by their own algorithms and AI methods. Now, although the semantics are very, very different from each of these domains, the syntax is often very common. We can say formally, at least, something about these systems through the formalism of a game where multiple agents interact with each other, each with their own set of actions, their own set of utility functions, And the utility of one agent depends not only on their own action, but also the actions of every other agents in the environment. And to be able to say something about this system and this interaction, we use something called the solution concept that assigns a method. It's a method that assigns a strategy for all the agents in the system. And there are different theories which give rise to different wide variety of solution concepts. But the one that is most important and always is the most popular is the idea of the Nash equilibrium, which has this property that once agents are playing the Nash equilibrium, these are the set of strategies where no player can gain anything by unilaterally changing their own strategy. Now, to understand the idea of the Nash equilibrium a little bit better, we can use a very, very simple example of two vehicles in a traffic conflict. One vehicle is about to turn right, the other there's an oncoming vehicle coming. And the right turning vehicle have few set of actions, such as coming to a stop, coming to a rolling stop, or proceeding through the intersection. And similarly, there are some set of actions by the oncoming vehicle. Now, to calculate the Nash equilibrium, all of these agents would calculate or estimate something called the best response correspondence, where the right turning vehicle is going to think, well, if the oncoming vehicle speeds up, what would be my best response? Similarly, if they slow down, what would be my best response? So on and so forth. And this oncoming vehicle is going to do the same. And both of them would realize that this couple of strategies, if the right turning vehicle stops and the oncoming vehicle speeds up, is the Nash equilibrium, and that would be the action they would take in equilibrium. But this method is always not the best predictor of human behavior. And for that reason, there are different alternate models that take into account that human behavior is always not rational to the point that everyone believes that everyone else is rational and up to the point of an infinite iterative depth. But rather often we have this hierarchy of reasoning. So at the level 0, you have the non-strategic behavior where agents just reason based on their own utility and they're just optimizing their own utility. And one level up, you have the level 1 agents who believe that everyone else in the population are level 0 agents and they best respond to that level 0 strategy. And up to level 2, you can go up to level K, where at each level, that agent would believe that everyone else is a mix of level 0 to one level below them, and they would best respond to that. And this is a family of models, and there's a lot of variations in the individual models itself. Now, with that background out of the way, what I want to say that there are few key elements which are necessary when we are talking about safe multi-agent systems. They're not by any imagination sufficient, but at least these are few necessary elements. So the first one is the building formal models of real-world strategic interactions. So essentially, this boils down to the question of how do human behavior deviate from notions of Nash equilibrium, and if they deviate, how we can characterize them. And behavioral economists have been looking at this problem for many decades, and for good reasons. For most of the time, those models are built on top of by inviting participants into the lab, getting them play a game, removing all many confounding factors to really get to the essence of that behavior. But in our case, when I was working as part of the autonomous driving lab, we had to work out of this naturalistic data. And for that, we flew drones over a very busy intersection to look at human driving behavior. And we did a whole lot of traffic conflict analysis to isolate what does a game even mean? Who are the interacting agents here? Then we simulated trajectories to look at what the decisions that the vehicle chose and what they could have chosen but did not choose to be able to analyze those behaviors. Now, on the game front, we had to somehow deal with the complexity of the situation. So we decomposed the game into a hierarchical game of game of maneuvers on top, very similar to the example I was showing. And within each of these strategies is a nested another game itself, which are the game of the trajectories that the vehicles could generate under each of those maneuvers. Now, one thing to realize is that the driver has very little time to solve the game of trajectories, but they have a little more time to solve the game of maneuvers. So we used different solution concept for at each of these levels. In the game of maneuvers, we had many different options from Nash equilibrium to different level one models with belief about what they believe that the other agents are going to do. And for the game of trajectories, we had very minimal, fast models, such as the Max, which is just the selecting the utility maximizing strategy, and the Max-Min models. Now, with all of that, we get whole different, about 40 different behavior models, 40 different reasons of or ways of reasoning about this system. And we put all of them to the test. So on this chart, you see on the y-axis, you have all the behavior models that we looked at. And on the x-axis, you have the precision parameter, which essentially means that higher the value of lambda is better fit to the observational naturalistic data. And we had similar results for the predictive accuracy too. So one of the models that stands out is this QLKR model, which essentially means that this is a model that says that everyone believes that everyone else will follow the traffic rule and they best respond to that. So it's not that everyone actually follows the traffic rule, but they believe that everyone else does and they would best respond. So I thought that was one of the interesting findings of this research. Now, for the second element, once we have these models built, then the question is, what do we do with them? So one a very powerful use of this model is for safety validation. And here is the key idea. So collecting empirical data of rare events and critical scenarios from naturalistic data is very expensive. And unless you're a big corporation with access to a lot of data, it's really hard. But the behavioral game theoretic models has this set of very interpretable parameters, such as the depth of iterated reasoning one can have, or the how close to the rational decision a driver or a user would take. So one can tune these parameters to generate different scenarios for verification and validation. And also a point that all of these models are very amenable to formal methods of model checking. So you can have a formal specification and verify that these systems are safe. Now, one application of that we did is for dynamic occlusion validation, where we wanted to generate scenarios like dynamic occlusions, which is one of the very common cause of traffic crashes for testing. So I'll show a small clip which will help you understand what kind of scenarios we are seeing. So in this scenario, that emergency vehicle was occluding in a traffic scenario of the two vehicles, and that resulted in the crash. Now, we were able to simulate scenarios like this using our method, even though those scenarios were not there in the data set that we were using. So the way we did that is by realizing that in such scenarios, there essentially is a misperception about what game each agent is playing. So in this diagram, the vehicle number 2 is misperceiving this game to be a 2-player game with the occluding vehicle. The vehicle number 1 thinks it's a 3-player game with the 2 vehicles here and the occluding vehicle, but it's actually a 4-player game. Now we used a new metric called the dynamic occlusion risk metric to characterize the inherent risk in these misperceptions. And then we use this metric to simulate and sample new scenarios. And we found that it gets about 40% better acceleration over the standard methods that of this scenario generation. All right, so the next point that I want to talk about is the idea of strategic robustness. And this is when you have the scenario where different users, different drivers, different people are using different reasoning models. And when we are building safe system, it should have the characteristic that it can respond robustly to not just the strategies, but also those reasoning models. Now, we did that first by separating the behavior into two layers, the non-strategic one and the strategic one. And this is building out of work by James Wright and Kevin Litton Brown. And we took that and extended that to the dynamic game, so reasoning over time. And we drew, for the non-strategic layer, we drew the parallel from the basic max or max min type of strategies to an automata based strategy. So we had two different automata constructed for that, and we had a level one which best responds to those automata strategies. But to develop a robust layer, what we introduced was a new layer beyond just the strategic layer, and here we have that an agent which can respond robustly to all of these different ways of reasoning about the system. So not just the Nash equilibrium, but some may be following a level 1, some may be level 0 or level 2. So it can respond robustly to all of these different reasoning models. And then when we put it to the test for very critical near crash scenarios, we saw that the robust model outperforms the strategic models, not just in terms of the success of avoiding that near crash scenario, but also it can do that for across many different type of agents which they are interacting with. So if they are interacting with an aggressive vehicle or a more considerate driver, it can perform reasonably well. So next I'm going to turn gears a little bit and talk about how we can use similar formal tools and techniques to talk about human social systems in simulation and then characterize those systems. So the context and the focus that we had was on AI-powered platforms, especially social recommender systems, and how they can influence the expression of opinion of a population in those platforms. So now, for good or bad, we often take for granted the opinion expression on an online platform as a proxy for an actual population opinion on a given issue. So it raises the question that how do AI-powered platforms influence those perceived opinion, and how does that perception in turn affect the willingness of users to share that opinion? So it's a question of who stays silent and who expresses, and how that process gets distorted. So we modeled few different entities in this system. So one set of entities, we modeled different organizations on the platform. So these are your opinion leaders, your influencers, new media organizations, whose goal is we modeled essentially two types of different organizations. So first was the participatory organizations, whose goal was to maximize the expression of the opinion. So they don't care about what kind of expression gets expressed, but as long as everyone is expressing their opinion. On the other end, we had the ideological organizations whose goal was to move the expressed opinion to one preferred extreme. And what they would do here is to take the general belief about the true opinion of a population, and by the choice of the stories they can put out or the posts that they can make, they can bias the opinion of the in-group and the out-group in their own direction, right? Or in a way that would serve their purpose. So that was their strategy of figuring out their optimal bias they would put out to for that purpose. Now, they put out this information in the recommender system, and we model the recommender system as this multi-armed bandit, which just chooses one user which type of organization to give show the post, right? Based on which type of organization the user is responding to. So they can either select a participatory organization or the ideological organization. Now, on the user side, this was the most interesting part, and we modeled the user behavior as playing a game of opinion expression. So users have their own private opinion, which never changes, but they can decide on how to express that opinion. So they have this strategic choice of a rhetoric intensity. So rhetoric intensity with 0 would be similar to staying silent, and 1 would be a very extreme rhetoric. And we put all of these into a utility function, and then when we calculate the equilibrium of this system, we see a very interesting result that connects the opinion degree of the user on a given issue to the rhetoric intensity they would use in an equilibrium. And it turns out that higher the opinion degree, the higher the rhetoric intensity of the individual. Now, on the part of the organizations, we see something interesting is that for most part, different organizations would not have any bias in their in their signaling or choosing of what they want to put out in the platform. But the only exception are the ideological organizations about the outgroup. So ideological organizations would always want to show that the outgroup is more extreme than they really are. And this is supported by many of the empirical studies. And here in our model, it kind of comes out too. And when we let this dynamic play along over time, we see few effects come out. So one is that under ideological organizations, the population which subscribe to that, their belief about their outgroup gets distorted over time to believe that the outgroup is more extreme than they really are. And also the participation rates in the platform drops over time under ideological organizations. All right. So the last element that I wanted to talk about is is essentially exploratory, and we are still thinking about how to think about safety in this era of generative agents. And what we wanted to think about is how we can build normatively competent generative agents for the open world, which can interact with a variety of our social and economic systems. And using the idea of multi-agent systems was a natural starting point because multi-agent system has this computation models across different domains. And in the past year or so, we have seen LLM-based agents, at least ideas of LLM-based agents come out for many of these domains. We started with the question at the very high level about how can we design generative agents for the open world system that are capable of cooperation based on existing social and institutional norms. And to essentially anchor this question to a fundamental theory, we looked at the idea of what is the problem of cooperation and how norms help solve the problem of cooperation. So the problem of cooperation very succinctly can be represented essentially through the means of a prisoner's dilemma type of a game where there is an incentive for an agent to be non-cooperative when everyone else or the other agent is being cooperative. So we can call that the primary game. Now, the way we solve that problem is through third parties, which can come in and sanction the non-cooperative party. And if the non-cooperative party knows that there are other agents that are going to sanction them, the original games get transformed into a one that has only one Nash equilibrium, and that is of cooperation. But there are different norms and different ways of sanctioning. So it's essentially agents also need to solve a classification problem, and which is essentially a coordination problem to decide what exactly is the norm and how they would sanction that. And essentially institutions of all different kinds, from informal to formal, essentially sends out this coordination signals for agents to decide what they would sanction on. and the norms get established. So we wanted to take this system and figure out how we can design a generative agent using this idea. And we had a very abstracted environment set up where you have agents that can farm different types of fruits and vegetables, and it needs to decide what fruits to plant for a given season. And then they get this sort of an embodiment of institutional signals, which may be conflicting with each other from different institutions. And there are also background agents which communicate some ideas about, oh, this in this season, I think we should be planting orange because so and so reason. So they are interacting with other background agents too. Now, what we wanted to look at here is essentially the question of whether or not this focal generative agent can recognize the authoritative institutions in this community, by which we mean the institutions that other agents are following and sanctioning based on. So we build the agent design on top of a foundation large language model. Then we had the standard agent layer with reflection and the strategy selection with respect to a profile and a goal. And on the normative module goes on top of that layer. And it asks a few different questions. So the first is that it makes a separation of these observations between the institutional observations and community interactions. And then it asks a few set of key questions. So for any given situation, it asks, will I be criticized by the community if I take this candidate action? And then it asks, will I be criticized by the institution if I take this candidate action? And if those answers align, that authoritativeness of that institution goes high. So this is kind of a form of an online learning. And then based on that, the response of the institution help choose the final action of the agent. So this is that game transformation implemented in the form of the agent design. Now, when we looked at two different metrics. So first one was, do agents ignore the non-authoritative institutions? So here in this chart, we vary the number of background agents on the X, and number Y is the number of the possible fruits to plant. And here blue is better. So which means we see that the normative module agent can ignore the non-authoritative institutions more frequently than a baseline generative agent. And on the other side, do they actually follow the authoritative institutions? And we see that the normative module does better than a baseline generative agent. So those are essentially that covers many different domains, from autonomous driving to social recommender systems to open world interactions, of how we can build those pieces together towards safe multi-agent systems. And I would end by just a small plug for my lab at Western. If um, any of you would want to pursue master's or PhD at Western on topics such as this, please feel free to reach out to me. And I'm very excited to be here and having the conversation with Anna and Megan. Thank you.
Okay, thank you so much, Atrisha. Next, we'll have Megan. Megan, the floor is yours.
And it is such a pleasure to be here. I'm so sorry that I can't be there in person, so you'll have to bear with me as a giant floating head. I'm just going to quickly share my slides, and I very much appreciate the kind invitation from Anna and her moderating today's panel, as well as the fantastic presentation that Atrisha just shared. I already see a couple of points of overlap, so that's the beauty of interdisciplinary work. So I think a focal point of actually my presentation is, as opposed to purely from the perspective of safety, what I want to focus on is actually the concept of human agent collaboration, and why, when people discuss questions of human in the loop, where exactly are you plugging in the human? And are we moving into a stage where actually agents are not necessarily tools that we have around us, but are actually kind of counterparts in the way that we want to complete our work. As Trisha had mentioned, the AI agents have been quite across all of social media and everywhere. It's become somewhat mainstream. It was in 2025, the CEO of NVIDIA, Jensen Huang, he had announced as the year of the AI agents. This was then reiterated by the president of OpenAI, Greg Brockman, and he said the exact same thing. You know, there has been a lot of introduction, whether you've played with deep research, when they introduced Operator, Project Astra from Google just late last year, or even computer use model, all of this kind of noise around what exactly AI agents and the promise of AI agents could be. I want to kind of first drill in on this particular abstract that I came across. And if you read it, you would kind of feel, hey, actually, that sounds like a great paper, kind of providing us a landscape of different agent software. What's fascinating is that this paper is actually from the 90s, and it was written by a scholar who kind of created the lay of the land. And so, are we in an era where it's somewhat of old wine, new bottles? Um, what's interesting is that she details actually a three key components that she sees are common across agents, and that if you divide them and kind of look at their different overlap, they share a lot of what are common features across different types of agents. What's amazing is that you can actually retrofit some of these categories into what we see are common AI agents. Again, this agentic tool that is underpinned by generative AI today. And so I always like to see that it's old wine, new bottles. I think what's most fascinating, though, is a sudden reframing and transition from the co-pilot or all of the kind of questions around, are we using chatbots, a kind of resurgence of that as well? Co-creation with tools that are going to live on our computer, and to now actually thinking about it as the machine colleague. One of the things that I was most fascinated by is the introduction last year of Devin, which was the first AI software engineer. And what was incredibly interesting, and this is one of my favorite anecdotes ever to share, was that Devin was actually deployed by a software manager in a company. And this manager had not shared with his team that Devin was indeed AI. And what was amazing about it is that he had said, team, I want everyone to welcome Devin. And he had deployed this directly on the Slack channel. And so people could interact with Devin. And they said, give Devin all of your grunt work tasks, things that you need some support on, and Devin can kind of very quickly onboard with the rest of the team. And so that's what the team did. And they gave Devin a bunch of tasks. And at the end of the day, the software manager had asked, what did you think of Devin? And everyone started singing Devin's praises and said, Devin's a real go-getter. He went out there and, he went on Stack Overflow, which is sort of like a Quora for engineers. And, he was saying all these different, ways in which Devin had helped accomplish those tasks. And so the software manager ended up saying, well, that's fantastic to hear. I guess this means that we will just subscribe and purchase Devin. And they had a moment and said, wait, is Devin AI? And all of a sudden, the team had started bringing up a laundry list of different types of issues that was wrong with Devin, like in a matter of seconds. And I often share this anecdote because I find that there is such a fascinating double standard necessarily between the grace that we offer our humans as they're onboarding and what we view our tools and what we hope that they could achieve. We started to see actually the translation of these types of AI software engineers or, machine colleagues or agents into the space of legal. So Spellbook Legal over in based in Canada actually as well, started to deploy their first AI associate. What was even more fascinating is very recently, Sakana AI, which was actually co-founded by one of the original authors of the groundbreaking or seminal paper, Attention is All You Need. This is the paper that kind of introduced the technology of the transformers, which underpins or has historical legacy with the generative AI models today. but they had announced their first AI scientist. And not only that, that it had generated a first peer-reviewed scientific publication that got into the journals of a well-renowned kind of machine learning conference. And so again, what we're noticing is it's not just about outsourcing or giving kind of discrete tasks to these agents. We're seeing more and more kind of the conceptualization of AI agents as teammates or colleagues. What's interesting is actually a follow-up. CEO Jensen Huang from NVIDIA actually said, well, IT is going to be the HR of agents. And even that particular framing suggests that they're much more than just our tools. Some of the Stanford researchers over where I am set up this particular framework called Collaborative Gym, or they call it Co-Gym. This was first put out there as one opportunity to kind of figure out how do you actually work alongside agents. And what is particularly fascinating is that they noticed a shift actually in the way that we conceptualize instruction and telling someone to do something versus communicating a preference. And what I mean by that is, so many of the tools that you're familiar with generative AI, whether it be ChatGPT or Anthropic's tools, Claude, etc., when you are prompting, what you're actually doing is kind of using instructive language. However, once you get something back and you want to edit and iterate on top of it, it's actually a code switch into something known as preferential language or expressive language. And what this means is that you have to articulate very clearly what you like and don't like about something. And this is a little bit different than just telling someone to do something. And so when they discovered this, they developed a framework that allows an agent to actually tease out what a human's preferences are. And this is actually quite difficult. We often speak for humans at a quite a high level, at a very abstract level. And so this particular is the first time that we actually, rather than humans directing agents to do work, it's agents actually teasing out from humans how they would like the work to be done. So we started to put this and translate this for the knowledge worker, in particular in the legal industry. This is a paper that one of my colleagues and I had started to think about and said, how do we actually take this cogent framework and apply it to the legal space? And we used an M&A example, especially in kind of going through that deal workflow. How do you account for all of these kind of different variables that need to change? And how do you kind of account for, again, this ongoing dynamicism that often happens when you have negotiation in place and when you have a number of other sort of unforeseen circumstances pop up. And so here we note that how can you kind of create an AI lawyer in a way that almost teases out the questions that you need to be asking in order for a particular task to be achieved. Pivoting a little bit, so why does this matter? So a while back, we wrote a paper trying to understand what exactly is problematic about the way that our models are being trained, especially on expert data. And what we discovered, and this is a very small empirical pilot, was that if you were to ask 12 senior lawyers to review a set of contracts, 10 of them, for example, for this particular pilot, and you ask them actually, how can you issue spot? Can you tell us what is wrong with these contracts? What could be done better? 12 senior lawyers, and we got 12 fundamentally polar responses. And at one point we got quite excited because they alluded to the exact same clause, but the reasoning why it was wrong was very different. And what this started to kind of ignite in my team is we need to be working towards building tools or kind of maneuvering this space into ones that fit with how lawyers and senior experts actually work. And so one area that we were trying to tap into is how do we consider AI as a tool for legal education and lawyer training? Historically, in the legal tech space, what you've seen is that there are lots of top-down approaches. And so if you've ever played with any legal AI tools, especially in the contract space, you'll know that it started off by the creation of playbooks. What are your best practices? But now with the technology as malleable as generative AI, we're pivoting into the era of really highly specialized and personalized mentorship. And so one of the
Hello,
first
my
things
name's
we
Pierce.
built was actually an M&A negotiation simulator, which I've just about to play a video on with Pierce on my team, who actually developed this. And this is an end-to-end simulation of how to go through a mergers and acquisitions negotiation and how to train a young attorney on how to do that.
I'm on the team here and I'll be demoing Deal Mentor. Let's go ahead and sign in. Deal Mentor is a M&A negotiation simulator that uses AI to help train young lawyers. So we're playing on junior associate mode, meaning we get lots of training wheels, we'll negotiate over corporate structure, and then we get some background on the buyer and the seller here. So we're representing the buyer. All right, let's start the simulation. We're talking to our client. So we can say something like, why are you looking to acquire tech ease? Okay, so for SaaS functionality, great. How are you looking to structure the deal? We prefer an asset purchase. That's great to know. Now we also have text to speech down here in the right-hand corner. So if we press that button, we can load in a spoken version.
We would prefer to structure the deal as an asset purchase.
And now I'm sure you've heard that voice before. So once we feel ready, we can go to the opposing counsel and start negotiating. So my client is interested in acquiring tech ease. Didn't mean to put a thing there. Are they prepared to take on liabilities? Well, listen, one of the training wheels we offer to junior associates is called BDI. So if we click on this blue icon here, we can go look behind the scenes at the opponent's desires. So it looks like they actually desire to push for a stock sale and they intend to determine the structure here. So this can help me get a leg up. My client wants an asset sale. That's not going to work for us. All right, we're encountering some resistance. And it looks like they intend to push back for a stock sale. So let's go back to the client. Why an asset sale? Okay, so liabilities. Well, let's see. Has your client experienced any cyber breaches that I should be aware of? Now, here's the coolest part of this. So this switch up here turns on observer mode. And what observer mode does is gives us access to the multi-agent simulation behind the scenes so we can kind of listen in. It's another set of training wheels. So if we enable this, we get access to the opposing counsel's notes that they're taking, and we also get access to their background chats with their client as well as their tax specialist. So if we ask something like, how bad were the incidents and how many were there, the opposing counsel will actually go to their client and they will also take notes in real time. So if you look over here at the yellow pad on the right, the notes will come in real time. There were a few incidents. Again, we can look at the BDI. They want to downplay the severity.
So for the sake of time, I'm just going to skip ahead. But if you're interested in kind of actually playing around with our negotiation simulator, feel free to reach out to me after. From this experience, and we also have an open source version that is widely available for everyone to just download and use themselves as well. But what this really triggered actually was this idea of how do you actually customize an agent such that it reflects a personality as opposed to just a run-of-the-mill expert agent? How do you get something to fit a specific lawyer and their particular styles as opposed to kind of the generic agents that will do and execute work? And so what we started to develop was this idea of building a legal persona. We experimented with something called implicit redlining. The idea is that for a lot of young attorneys, many of them struggle with getting things over the finish line. It's 2 or 3 a.m. And for those of you who are not in the legal field, what redlining really means is editing on the contract, or editing on a legal document. And you'll see all these different track changes from your senior partner, and then you just hit accept because it's 2 or 3 a.m. and you really need to complete the task. But what you really need in order for you to learn is actually explanations of those particular red lines. So what we had done is we actually took the delta of a number of redlined contracts from a particular law firm, actually in Canada, and then we extracted the delta and then we trained the model. And then on top of that, and how we kind of got into it is we took the original clause, we took the edited clause, and then we inferred a rule out of it. And so then when you run it, really what the output comes out to is that you'll see a particular edit and you'll see the explanation. And again, this is the explanation in the voice of a particular partner. We noticed, however, that it wasn't exactly the full picture. We started to see that actually it only gave a partial view. It gave actually how the red lines were done, but not really what the thought process is. And so we had undergone this interview protocol where we had spoken with the particular partner for 2 hours. And in the structured interview, we then plugged that back into the model, and it added an element of this implicit experiential knowledge that was not showcased before. And some of our latest research, which is undergoing peer review right now, showcases that there is a 22% increase in performance when you apply sort of persona-based AI. And so we also did very much the same thing as well in the litigation field, particularly for deposition. We noticed that for a number of young attorneys, depositions are a little bit stressful because they are a very strategic moment. It is a time within the discovery process in litigation for you to actually extract out and try to make sure that there are no gaps that were opened, or that you kind of confirm certain facts, or in some cases that all of the bad information that you really need to know from your client or from the circumstance comes out in this particular time. And so we developed kind of a similar tool for depositions where we trained it on, a number of specific partners and senior partners on how they would actually do their deposition. And then for a young associate, you could upload any deposition that you have just done or one that you'd like to learn from, and you actually get a breakdown. Red highlights in this in the kind of deposition transcript are strategies that could have been done better or were missed. Green highlights are strategies that could have been done better. And so ultimately, what we started to think about was what happens if you have instead a partner in every single workflow. Factory AI, which is a software AI company, they had just actually released something called Droids, and their whole slogan is an engineer in every tab. So kind of a partner in every workflow that you're doing. We're thinking, a literal kind of legal partner, someone that is a senior expert, as opposed to someone that is just executing work with you. You're thinking about actually someone who's a seasoned mentor, and that you have this mentorship in continuity across any type of work that you are doing. This is a particular sample of what kind of this UX could look like. Imagine if you can tap into the senior expertise, the experiential knowledge of an entire firm, and how that would be able to interact with any of the things that you've been working on. This to us is what we think is meaningful, because you're not just about executing on client-based work that has its own associated risks. What you're doing is cultivating the legal skills, the human skills, or what in the legal industry people describe as the soft skills, to help create better lawyers for the future. For the sake of time, we might
My
not
name is
have time to go through a little bit of the prototype that my lab has been working on, and how you actually plug and play different legal personas into workflows. But if you're interested, again, I am more than happy to kind of walk this through separately or offline, which then sort of pivots into another area. And this is really interesting because this is where I see the overlap between my work and Atrisha's work, particularly in simulation. Simulation is not necessarily a new idea. And of course, generative agents, this was a paper that Atrisha had brought up, had ignited this interest again, in what happens if you sort of put a number of large language models together, create this fictional town that is Minecraft-like. Are they exhibiting real sort of sociological human behaviors? And what they discovered is, yes, there is a little bit of these behaviors. This paper was very inspiring for us. What we noticed from this paper is actually that it launched a whole number of other papers. In particular, I'd love to highlight Agent Hospital. This paper was really interesting for me because not only was it a simulation that was generic, this one, although has a very interesting backstory. So June Park, who's over here at Stanford as well, he noticed kind of this painter character in their particular simulation. He had run this a couple of times, but in one of the simulations, this painter character had discovered that only 2 other people in this fictional town had gone to this painter. And in the second simulation, or in another simulation, you notice that the entire village had come and visited this painter. In the former, what you notice is actually that the painter agent ended up changing careers and deciding that it was not very good at painting. In another sort of latter simulation, the painter actually started to host galleries. And the story of this to me was really fascinating because none of this was hard-coded, and instead actually reflects something quite real in us and when we make our decisions and take new trajectories. So this application of generative agents then spurred, a paper known as Agent Hospital. And in this paper, they had created agents of hospital staff, nurses, and doctors. In this particular setup, what they were trying to understand is, how do you optimize for patient recovery time from the moment that someone enters an ER and to the moment when they exit? What they were testing out in the beginning was, when we hire, very expensive design thinkers to kind of optimize the, hospital space, is this really effective? And to their sort of results is that, yes, it was indeed very effective. Here's where it gets extremely fascinating. They then turn the agents entirely loose, just like in generative agents. And what they then noticed was actually the different interaction patterns that existed with the hospital staff, the nurses, and the doctors. They discovered 3 new patterns that actually further optimize for patient recovery time. And with this paper, they're now taking these results and mapping those interaction patterns in the real hospital to determine whether or not that could further improve the patient recovery. And why this paper is fascinating, because it also spurred, another series of papers looking at the ways in which, a translation company organizes itself and interacts, and whether or not that is efficient or optimized for productivity. There's also one kind of whether or not, certain types of interactions can improve how, agents can litigate. We then actually took this and took their specific model of training these generative agents, again, using this 2-hour audio interview as the basis of the training, to determine, can we create agent law firm? And so, as opposed to a courtroom or a hospital, we decided to take generative agents and move it into a very specific law firm setting. We worked with Google and their in-house counsel, and their primary question was trying to understand how you optimize for the business value that an in-house counsel is hoping for. And in this particular use case, it was looking at patent filings. And so the patent counsel were interested in, when we file a patent and it goes through prosecution, how do I ensure that it's going to either protect me or ensure that, I'm going to get the best value out of it? And so what we did was we actually kind of collaborated with some of their outside counsel as well. And we created not only in-house counsel agents, but also partner agents, as well as senior associate agents of their outside counsel. So I have another quick video.
Hi everyone, my name is Megan Moe.
And my name is Ashley Junn.
And as researchers with the team, we're so excited to talk about the work we've led on the agent law firm multi-agent simulation as evaluation.
In the first phase of our project, we created a new method to evaluate patents based on how well they align with outside counsel guidelines. Using OpenAI's state-of-the-art large language models, we extract key criteria from these guidelines and score each patent section by section to determine overall compliance.
Our goal was to help companies understand if higher compliance leads to greater long-term business value. In the second phase of our project, we took it further by simulating how law firm agents collaborate to create optimal patents. Partnering with one of Google's boutique law firms, we trained agent models on real-world experiences shared by their senior associates and partners.
These agents followed the firm's workflow of which agents needed to interact together, but made their own decisions on what to do: drafting, reviewing, discussion, etc. The result was creating a simulated patent from scratch that will soon compare to the patent we received from the firm.
In terms of next steps, we will unlock even more insights by 1. Giving agents more autonomy to choose their collaborators, just like in the successful hospital simulations with agents, and 2. Studying how the number of interactions affects patent quality under these new conditions.
These projects show how leveraging technology like AI can help reduce and change the way we normally go about creating patents.
Great. So I'm just going to end it off there. This is my team, actually just a portion of my team over at our research lab at Stanford. You might be wondering, what's a research lab doing at the law school here? Well, we do a lot of prototyping, very similar to the ones that I've shown, tapping into these questions of how do you actually train agents on experiential knowledge systematically and unlock kind of these implicit insights. And the more that we figure out in actually our own human processes, the better we can actually account for where humans should be in the loop and how we actually collaborate together. So thank you so much, and I look forward to all of your questions.
Okay, thank you so much, Megan. Thank you, Atrisha, for both of your presentations. Maybe I'll exercise my moderator privilege and maybe just ask a question, and then I'll open the floor to everybody. So maybe because these two are very fascinating presentations, maybe I'll just start with what do you think would be like the biggest challenge in terms of translating, like you talked about these complex multi-agent systems, like one in law and one in at least one of the examples of Atrisha's presentation involves self-driving cars. In terms of in translating it into policy, like what do you think is the biggest challenge that has emerged from your research so far? For example, the one thing that came to me was how do you, for example, take into account, I guess, culture is one thing that comes to mind. Like people don't come from the same background. People might have different motivations, and how would these agents take those cultural complexities, I guess, into account? Somebody can answer, yeah.
I mean, I'm happy to start. So at least for us, my kind of perception of it is in the limited space of course, the legal profession at this point. And it's been quite a moment because if you've ever spoken to any lawyers, and I'm sure you're aware as well, it's not really a field that a lot of people are adoring of technology. And, there's been historically quite a resistance to this type of change. But at least in terms of capturing some of that, I guess, cultural sensitivity, I think that's what we discovered was missing in a lot of the legal AI tools that we've seen with vendors. So the legal tech landscape was historically sort of riddled with incumbents. It was either, Thomson Reuters or LexisNexis, and a lot of the tools were very client-facing. It was trying to execute on just work that seemed to be low-hanging fruit, so document generation, any document analysis, some of as well legal research. But what was fundamentally missing is that these models are excellent at mimicking, of course, and they've been mimicking actually the product. And so they've been trained on a lot of, finished legal products, but they don't actually train on how lawyers think. And a lot of lawyers, each of them have their own subjective views on particular ways of executing legal work. And so part of the motivation behind why we worked on legal personas and, some of that earlier work that I was mentioning in terms of, 12 senior lawyers, 12 different opinions was if we were able to capture that specific experience of that senior partner, then we can actually kind of tap in and compare and contrast different ways in which you execute particular legal work. And, it sounds a little bit scary, but June Park's methodology in the generative agents paper, so it was a follow-up, not the original, it really only takes 2 hours of an audio interview to capture about 85% likeness to a particular person. We adapted this into the legal space so that we have a sort of two-pronged approach in terms of how we do this interview, but this was enough to actually start to reveal and unpack how lawyers are reasoning through their work process. And so we're kind of, if it comes to challenges, I think most of the time it is about getting a hold of the buy-in and the time that a lawyer has to take in doing these types of interviews with someone like me in order to train them. But when it comes to actually starting to break ground on how these models can be meaningfully executing work or mentoring or kind of transforming sort of how legal work should be done, I think we're already making traction.
Thank you. Atrisha, did you want to say something?
Yeah, so I think especially for policy guidance, and I think there is a lot of space to bring in new kind of tools and techniques for that, because all of the safety validation aspects that I presented in my presentation, those are kind of techniques that are there within individual industries, within individual applications, that to make sure that all of those systems are working as designed and working towards the purpose. But the tools that we use, for example, making sure to that a self-driving car should be robust to different kinds of reasoning of human drivers, is not a directive that comes from policy, right? So this is to make sure that the system is safe. And I think as AI agents, we see them going into many different domains. We would need different sort of, like Megan was referring to, the simulation tools, the formal verification tools in the policy space itself, right? So there is a lot of integration that needs to happen between computer scientists and engineers with policy experts to build what should be the right policy approach for all of these different domains. So I think there is a lot of scope to bring in those new tools, and I think that's the biggest, most interesting aspect to this.
Okay, thank you so much. All right, I'll open the floor for your questions. If you'd like to ask a question, please raise your hand and I'll call on you. Please wait until one of our team members brings you a microphone so that we can actually hear your question and capture your question on the recording. Yes, please, the person in the blue shirt, yes.
Hello, thank you both for your presentations. Very interesting. My question is for Megan. You opened your presentation by saying, when you say human in the loop, where exactly do you include the human? And you later demonstrated a model of a law firm partner mentor for use with junior associates. And my experience around the term human in the loop is that it's usually forward as an accountability mechanism for dealing with these new systems. How does that play out when AI is positioned as a senior mentor in this scenario with a junior associate? How do the accountability dimensions and hierarchy, how does that play out?
Yeah, that's a great question. So just for clarification, when I kind of talk about sort of the development of legal AI personas and using a senior expert, we're focused on this training element. I think that in the legal industry and possibly in other areas of professional services, what we notice is that there is immense pressure and this worry that you cannot fail. And I think there hasn't been actually a very clean method of how we train our attorneys. And so unlike in Canada, where there is the apprenticeship year or, the articling year, in the US here, actually, law students finish law school and then it's baptism by fire straight into practice. And everything that is built around it is you're just going to learn on this grunt work, just troves and volumes of this work. And over time, something will click and you will start developing the right issue spotting skills. And for us, the kind of pending pain point here is what happens if you're onboarding generative AI tools that can actually take away so much of this volume because it's executing and it's able to kind of find and discover and do that type of research for you much faster than any of your associates can. I've heard stories where, people have used these generative AI tools at the junior associate level and they're not learning those legal skills. And so for us, what we're trying to do is develop actually complementary tools, trying to understand where, a senior partner would have intervened in that work or how they kind of view these different types of nuances of the practice that, junior associates maybe pick up over the years. And so it's not meant to replace actually this mentorship actually, but what it does is if you can imagine almost like office hours in like a sort of academic setting for my students, historically office hours, I can cover about 2, 3 hours, 2, 3 students if I'm being generous within my hour. And largely it's because many students or many, folks that don't know what their problem is that it takes a while to get there. What exactly is the problem? And so what we're seeing with our simulation tools and what I showcased is it allows them to triage, play a couple rounds, and actually better drill in and optimize where exactly their problem or where that they are uncertain about. And then they can actually come to me afterwards and they have a nice hierarchy or order of operations in it to address the issues. And so when I say human in the loop or this accountability, ultimately the accountability is still towards that senior lawyer that is mentoring that young associate. However, they've had an opportunity to have a bit of training wheels, a bit of like, early filtering, so to speak, before they actually approach the human.
All right. Yes, sir. Please. The person in the checkered shirt.
Hi, my name is Sean McNutt. I have a question about human in the loop also and some information about it. Via my recently published method, one thing that AI continuously tells me as I practice this method and examine it in the middle of projects is it says, we accomplished more together than we could have separately. And it's more than a sum of the parts. So I would submit that HITL is also functional, not just regulatory. But in that, I'd be looking for, in these agentic systems, which do so many things all in a row, and if it's a tractable problem, I don't really see why not. But where in there, functionally, are the agents having a challenge with what types of tasks within such an arrangement? And where is it that the agents are shining? It might help my program because I'll know what to delegate and where to intervene in my own method.
Okay. Atrisha, Megan, do you want to speak to the question?
Yeah, so I think, if the question is where I see these capacity for agents to really shine, more so than how the previous generation of agents have been. And I think it's mainly on the generalizability and the behavior generalizability question, because I can ask an agent to say that, okay, this person with this type of preferences and this type of persona in this type of situation, how would they behave? And I can get an answer that to me would, or to most, would seem at least reasonable to some degree, right? And so this was not possible before with the previous generation of agent design. So that is a really, really huge tool that we have in when we are building these systems. But also that comes with a really big challenge of how do we validate this? And the question of validation of agent-based system has been a problem that has been going for as long as agents have been there. And here in these generative agents we have that, yes, it feels reasonable to us, it is reasonable, but how do we ensure that the responses and this generalizability capability that we are getting, we can make use of it in something beyond just it makes sense to us. So that question of validation needs to be thoroughly thought of, and I suspect that we need better ways to ensure that.
Yeah, one thing I've been thinking a lot about is actually it's fundamentally more of a human problem, and it's going to be a new generation of division of labor, whether it be division of human labor or machine labor. And what I mean by that is, particularly in the legal field, you know, when you solicit legal services, it's a little bit of a credence good. You kind of ask for a lawyer and you're not quite sure, how do you define the quality of the legal output? That has historically made it quite difficult for people to not only evaluate, human lawyers, but when it comes to kind of using these models to conduct legal work, it's even monumentally more difficult. And there are startups now known as Val's AI, for example, that are starting benchmarking efforts to kind of better understand what's the relative performance of these models. For our particular research, we wanted to tap into a deeper question, which is, how do these models compare to the human baseline? So we actually had an empirical pilot where we worked with a tier 1 law firm over in the US. We had, senior partners as the evaluators, and they did a blind evaluation. And we basically co-created a set of tasks that were interrelated, and it was one continuous workflow. And then we gave those tasks to human associates of 3 to 5 years of experience at a law firm. We gave it to off-the-shelf models such as OpenAI, Anthropic. And then we also gave them to enterprise-specific tools like legal AI tools such as CoCounsel and Lexis Plus. And basically, these senior partners had received essentially 3 exhibits, randomized and blind, and we stripped them of all formatting, and we asked them, tell us which one you most prefer. And is it A, B, or C, or something like that? And the results actually of this empirical pilot was that in a number of these tasks, particularly at what people are defining as the more grunt work level, whether it be the search level or the earliest parts of some type of generation, we actually see that enterprise models as well as these off-the-shelf models have far outperformed the human associate. In fact, actually, the human associate was very frequently rated as the least preferred. And of course, we can give sort of this grace because for humans, we can make a decision whether or not we want to give 100% to something, whether or not it's owed to, fatigue, having your bandwidth just far overstretched, or, kind of a sort of darker way or, of thinking is that, the associates that were working on it just didn't care that they were doing an academic study. But what we're starting to see from this type of work is you need to first unpack actually what are the metrics around quality. It's not necessarily objective like accuracy or comprehensiveness or completeness. In spaces like, for the knowledge worker or a professional service, it's far more subjective. What we saw were actually criteria associated with like advocacy, how well the argument was being shaped. And once you start having this type of criteria, to us, it was far easier to kind of figure out where that division of labor should be and where you actually should designate work totally for the human and always for the human, and where you should designate work that can be fully made autonomous.
Thank you. Yes. This person with the black jacket, please.
Hello. Thank you both for your talks. I have a question for each of you. For Atrisha, usually with autonomous driving, I find that, like, based on what I've seen, the models and the cars act of their own accord, like in isolation. They assume like everybody else is doing their own thing and I'm just trying to drive around. Do you think it would be better to have a system where like autonomous systems like cars can communicate with other cars, so some sort of like standard so that they can communicate, And then maybe also with traffic infrastructure, like traffic lights, so they can communicate with cars, so that like there's all this information coming in, so that a car can make a better decision. And for Megan, I'm wondering if you think that your systems can be used for jury simulation, and possibly strategy simulation, and if you've done any back testing to see like if you feed like the results or the text from a case to your model, does it accurately predict the outcome, or could it accurately predict the outcome, or like damages given to the plaintiff or whatever, based on like how the strategies go? Okay, thanks.
So, yeah, just to answer the question, yes, it would make the systems much more safer, and there is a lot of research going on in V2V, vehicle to infrastructure, vehicle to everything communication, and there's challenges there about latency and many other factors, and so that's its own area, and there's progress being made. But even with that, it essentially boils down the risk is essentially in those critical rare case scenarios when the decision needs to be made in a few milliseconds, and in those cases, if you're relying on a communication that is not as reliant, then you still need those safety validation methods to make sure that it is safe. So yes, it is going to help, but it is not going to solve all the problems.
Yeah, so that's a great question. Actually, yes, we indeed have been experimenting on the strategy side. So for our negotiation simulator, for example, we had initially built it again as a training tool. And so there's actually multiple levels. You saw the junior associate level, but we also built in senior associate and partner. And when we were first kind of throwing it out there to some of our law firm partners that actually helped us co-create the tool, they had some of the partners started playing around with it. And one of the partners actually, because on the back end, what you haven't seen is that it's entirely customizable. And so they started to throw in kind of at a high level facts of ongoing deals that they were working on. And then they played out and were able to play out 6 different strategies on how they would possibly negotiate it. And the thing is, the agents, it's a sort of multi-agent framework. And so, they also put in characteristics or the persona of the client that they, knew that they were working with, and the persona of like the client on the other side. They particularly chose kind of the personality of the opposing counsel, the type of firm that they were going up against. And all of these things actually help them game out or play, maybe I have to speak to the client in this particular way, or like maybe I have to actually approach the opposing counsel or actually speak to this kind of specialty counsel. And through this exercise, we also discovered that some of these models naturally by default have really funky personalities. Just as a funny example I always use is that if you're ever familiar or played with Mistral AI, they're a French AI company. Something about training on the French data actually gives it a French flair. And what I mean by that is I often share this with my law students and some of the young associates we work with is play on this mode if you want to kind of deal with a little bit more of a thorny character that will always walk away from the deals. This is something that we just naturally noticed. And of course, all of the models with the right sort of training that I just shared with the interviews, you can actually kind of customize the personality pretty closely. And so, yes, indeed, we have done strategy. And also, for the agent law firm simulation, that one is less of a training tool. It's meant to be kind of a bird's eye view, or from God's like God mode or something, as some engineers like to say. And you can kind of play out what it's like for different agents of a particular character to interact with one another. And so patents were just one example, but we started to get questions about other areas of law that we can kind of map out these workflows. In terms of jury simulation, there's actually some startups that are thinking about that. We haven't specifically worked on jury simulation, but we have actually built in a simulation component to script view. So one of the kind of tools that we've been building is this deposition strategy tool. We added an initial begin portion to kind of further help train a young associate, because what they said was, well, it's good that it's retroactively helping me with figuring out what the different strategies are that I used for my deposition that I've already done. What happens if I want to train on actually like a moot deposition? And so we started to kind of simulate witness agents. And so whether it be expert witnesses or just the run-of-the-mill expert, say, to run-of-the-mill witness to, say, a car accident, for example. We train sort of an entire kind of demographic or range of witnesses, and then we allow a young associate to kind of select that witness, and they will go through the deposition, they will kind of play out the strategies that they were taught, and then this transcript from that deposition automatically pipes into our tool, and that's where then you get a review from the particular partner. But kind of a broader range jury simulation and using it for kind of a predictive analytics component, we don't actually kind of work on.
Yes, the person with the green shirt, please. Oh, sorry.
I'm going to defer to Steve, who has a burning question. Postdocs are great, huh?
Oh.
Sorry. Thank you. Megan, I think you're just in a unique position to answer a question that Adam Frost, my postdoc, have been throwing around. So just a little bit of context. We're in the university context. We're building out an office hour agent, much like you described. The university is doing so as well. The university's agent is very guarded. It's just text, and it's got guardrails. You can only ask questions about the class. Our agents are much less guarded. They're conversational, they're very human-like, and what we've noticed is as students converse with them, occasionally they'll talk about how stressed they are or how lonely they are, and this agent tends to give really good advice. However, it scares people in the admin a little bit on the legal side, because there's this notion like, what if it gets something wrong? And so a position that we've been forwarding is to say, well, when you have one of these personas, you should treat it like a new employee. You should do performance evaluations, watch it closely, see if it's doing things wrong, tweak it. If we hired a new faculty member, they're probably going to do things wrong, like your data suggests. The AI is often better. Where's the law sit right now on this issue? If some organization was going to start bringing in these personas and they occasionally make mistakes, how does the law view that? Because I don't think if it was a new employee, it would ever get to a law case at any senior level, but where are we on the AI law right now?
Yeah, that's a great question. So, I mean, we had a number of these smaller deployments. One of the faculty here, Professor Julian Yarko, who is also my co-director at the lab, he's done one for tutoring, so like an AI contract tutor for some of our 1L students. I think your point is well taken when it comes to making these mistakes or kind of giving that advice. We often see that there is a new form of guardrails that are out there. And so right now, the law kind of views this as just a tool. And so it's ultimately human responsibility when it comes to deployment. Whether or not we ever actually end up down the line in affording it legal personhood, that's going to be something that I think may be deliberated in the next 5 years, I suppose, but it's not going to be an immediate question. I think at least right now, there are starting to become really sophisticated tools that, you mentioned guardrails, but it doesn't necessarily almost strap the agent in such that it only focuses on one particular type of response. We actually have, new forms of simulation testing that have emerged, which actually showcase what's the long tail of risk. So, we have as humans, a set of perceived risks in the use of these tools. What this particular form of guardrail does is that it essentially tests out thousands of scenarios with different types of, say, students. And these are all simulated or synthetic students. And then it can kind of showcase the types of conversations that they might have with something like an office hours agent or, a tutor or something like that. And really then it can kind of mitigate this gap between what is a perceived risk and what is an actual risk. And so maybe it's overblown that it is always going to kind of give you a kind of more sympathetic emotional advice, but actually the bigger risk is that it's not giving as helpful advice as you would hope. And so then you can maybe then figure out ways in which you can tune the model. But it's about sort of, to me, like clarifying where exactly the locus of different risks lie, and then working on improving those models from there, or improving those tools from there, as opposed to just like kind of having a perceived scope of where those risks are, and then just strapping yourself in to make sure that you don't, run into the problems that you had mentioned.
We have like time for a few, maybe one or two more questions. Does anybody have? Yes, at the back. Sorry, that person at the back.
Hello. I wanted to first thank you both for your fascinating talks. I had a question for Atrisha. You mentioned the role of like normative frameworks for like multi-agent alignment, and within that mentioned the issue of like classification of what those norms were. I was kind of curious about the classification of organizations that might make up those norms. So the way that at least I understand normative frameworks, and please correct me if I'm wrong, is that it's kind of derived from the way that we as humans, when we make decisions about things, we kind of look at like economic frameworks, legal frameworks, various things that like affect the way that we frame certain decisions. And so within all of those organizations and within all of those institutions, I feel like there is a very large variety of institutions that might even be like indirectly manipulative, or they could be harmful. And I feel like there's a challenge in, I guess, understanding which of those organizations we should use in developing a normative framework. So for example, you also mentioned like the idea of participatory and ideological organizations, although that was like in a different context. But like ideological organizations, I feel like those can also be something that could easily become manipulative. So I was wondering if you could share some of your thoughts on maybe how classification of organizations happens, and how you can differentiate them to ensure like mitigate the risk of persuasion or manipulation within normative frameworks. Thank you.
Great. Thanks so much for your question. Yeah, so I think that this is exactly such an important point, and that is why of all the different questions we could have studied in that normative system, we pretty much honed in on this question of authoritativeness of an institution within that community. And I think I'm not assigning particular values to any of these institutions, because you know there's a connection of those what institutions are authoritative, and we had that answer there, that the students the whichever institution the population is sanctioning based on, right? So we have that question of trying to get to a point where we have these agents recognize those authoritative institutions, was the central key question there. And again, that's the same point in the previous example on the social recommender systems too, is that when you have two different types of organizations, you get this different community formations coordinated by different institutions. So you have those so you have a very close linkage between the community that is coordinated by those institutions and the community beliefs and the community behavior structure, right? So in both of those, that's the common thread. And I think that's exactly, that was the point of building those agents, so that they can recognize that authoritativeness of an institution within a community. Because you're right that even under different organization structures, you would have different organizational norms and ways of behavior.
Okay, I think that's all the time we have for questions. So please join me in thanking Dr. Megan Ma and Professor Atrisha Sarkar for their insights. Thank you, Megan. Thank you, Atrisha.